Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about the properties of the logarithmic functions. So one of the main reasons why we introduced the logarithmic functions is to be able to solve the equations which involve the logarithms and the exponentials. And in this regard, so sometimes we will get this kind of expressions where we need to find the x. And that would be really cool to know some of the properties of the logarithmic functions, which would deal with this kind of problem. So essentially, it appears I can write down this expression as the logarithm of 2 of 4 plus the logarithm of 2 and x, and I know that this is going to be equal to the 2. So you see, so I can just find the logarithm of 2 of x by just applying the properties of the logarithmic functions. So today we are going to discuss about the three properties. Essentially, the first property is going to be the logarithm of u and v on a base of a is going to be equal to the logarithm of base a of u plus the logarithm of base of a of v. The second property which we're going to discuss is going to be the logarithm of base a, u divided to the v. It's going to be the subtraction of these two logarithms. And the third property which we're going to discuss is going to be the logarithm of base a of u in the power of some c is going to be equal to the c times the logarithm of a u for any real number c. So this is c for any real number c. Okay, so let's try to prove all of the three properties of the logarithmic functions, and I will give you some examples on how to deal with these properties. And in order to prove them, I'm going to introduce a couple of functions. So essentially, let's say r is going to be equal to the logarithm of base a of u, and s is going to be the logarithm of base a of v. So at the same time, we know that if I take the exponential from both of the parts, so essentially a in the power of r and a from here, what I will get here is essentially a in the power of r is going to be equal to simply the u, right? And at the same time, a in the power of s is going to be equal to simply to the v. So this is because of the fact that the logarithmic functions, logarithms, are the inverses of the exponential functions. Or this is essentially because of the definition of the logarithmic functions. So now what I would like to do is, so it's really important to memorize these functions because we're going to come back to these functions lots of times. So now let me define the multiplication. So the first property. What I would like to do is I would like to multiply u to the v, right? U is equal to the a in the power of r, and v is equal to the a in the power of s. So I'm going to write this down. So essentially, a in the power of r times the a in the power of s. So at the same time, we remember the property of the exponential function is that if you multiply the two exponential numbers or functions with the same base, you can just add their powers, right? Their exponents. So it's going to be a in the power of r plus s. So what I would like to do is I would like to take the logarithm of the base a from the both of the parts. It's going to be logarithm of base a of the uv is equal to the logarithm of base a of the a r plus s. And again, so logarithm is the inverse of the exponential function, so that's why it's going to cancel that out. And what we'll have here is the logarithm of base a of u times the v is going to be r plus s. And do you remember what was r and s? So r and s are the two functions of the logarithmic functions of the u and v. So essentially, it is going to be the logarithm of base a of the u times the v is equal to the logarithm of base a of u plus the logarithm of base a of v. So essentially, this property of the logarithmic function is coming from the property of the exponential function, which tells you that, hey, the powers of the multiplication of the two exponential number with the same basis is going to be just their sum. So I gave you the example for this one, so let me give you one more example. So let's say sometimes you need to deal with this kind of equation, logarithm of 2 of 8 and x right? So then you can just write this down as the logarithm of 2 of 8 plus the logarithm of 2 of x is going to be 3 plus the logarithm of 2 of x. So let's try to prove the second property. So I'm going to use the same functions here. So if you want, I can just copy them here. So let me just copy, because we're going to use these definitions for all of the time. So I'm going to copy them. Okay, so now let's talk about the second property. The second property was the logarithm of base a of u divided to the v is equal to the logarithm of base a of u minus the logarithm of base a of v, right? And if you remember, we have defined those functions of the u and v using the exponential functions, right? Like this. So what I would like to do is, first of all, I would like to find the u divided to the v. So let me do this. U divided to the v is going to be a in the power of r divided to the a in the power of s, right? Because u is equal to this one and v is equal to that expression. Okay, so what I'm going to do is I'm going to use the property of the exponential function is that if you divide the two exponential numbers with the same basis, you can just write this down as a in the power of r minus s. Then we can take out the logarithm from both of the parts. It's going to be the logarithm of base a of the u divided to the v. It's going to be the logarithm of base a of the a in the power of r minus s, right? And we know that these two functions are going to cancel each other because they are the inverses, right? And we'll have just the argument of that function there on the right-hand side part. So it's going to be the logarithm of a u divided to the v is equal to the r minus s. So I'm going to just substitute the r with the logarithm of base a of u and s with the logarithm of base a of v here. So it's going to be the logarithm of base a of u minus the logarithm of base of a of v. So this is essentially the proof of the second property of the logarithmic functions. And I would like to try to prove the third property. So, okay, so let me give you some example here as well. So sometimes maybe you need to find the logarithm of base 4 of x divided to the 64, right? So you need to get rid of the 64 and you can just apply the property of the logarithm and you can just write this down. Hey, logarithm of base 4 of x minus the logarithm of base 4 of 64, and this is going to be the logarithm of base 4 of x minus 3. And the last property which we would like to discuss today is the u in the power of, oh, let me write this down. So the logarithm of a u in the power of c is going to be equal to the c times the logarithm of a of u. And again, we're going to use the properties of the exponential function. So let me put here the definition of, let me put here the definition of the functions which we introduced so far. Okay, so here you see, so the u is given as the a in the power of r. So I'm going to write down what is the u in the power of c, first of all, right? So this is going to be a in the power of r in the power of c. So we know that by the property of the exponential functions that the u in the power of c can be written as the a in the power of r times to the c, right? So now I'm going to take the logarithms from both of the parts. So let me take this logarithm of base a of the u in the power of c, and it's going to be equal to the logarithm of base a of the a in the power of r times to the c. Okay, so you see, so that this function is going to cancel out this one again. So it's going to be the logarithm of base a of the u in the power of c is equal to so this log and this log is going to be canceled out. So r times to the c. So at the same time, I know that r is defined as a logarithm of base a of u, right? So what we are going to do is I'm going to write down the logarithm of base a of u in the power of c is going to be c times to the definition of the r, which is logarithm of base a of u. So it's going to be the logarithm of base a of u. So this is one of the important properties of the logarithmic functions as well. So for example, if you need to get rid of the powers of the x, essentially if you're given the logarithm of base 2 of x squared, but you still need to find x, you can just apply this rule and write this down as a 2 times the logarithm of base 2 of x. So let me do an example to solve some problems with the logarithmic functions. So for example, let's say you are given, so let's do an example, an exercise to solve the logarithmic equations. So let's say you're given the log of 2 of x plus the log of 2 of x plus 3, plus 2, sorry, plus 2, and this is equal to the 3. Okay, you still need to find x. So you see, so you can't really apply the exponential function from here and from here in order to get rid of all of the logs because it is not going to cancel these two logs at the same time. And again, in order to cancel out all of the logarithmic functions, we need to just unite them, right? Combine them together. And we can do this using the first property of the logarithms, which tells you that, hey, the summation of the two logs with the same base is going to be the multiplication of their argument. So it's going to be the logarithm of base 2 of x times to the x plus 2. This is going to be equal to the 3. So now we can apply the exponential functions in order to get rid of the logarithmic function. So here, what I'm going to do is I'm going to just put the exponential function from here. So it's going to be 2 in the power of this log, and it's going to be 2 in the power of 3 from this side. So this 2 and log are going to be canceled out because they are the inverses. And what I will have on the left-hand side is going to be x times, so it's going to be x times to the x plus 2, and this is equal to the 8. Then it becomes a simple quadratic function which we can solve. So it's going to be x in the square plus 2x minus 8 is equal to the 0. So you can use some of the formulas in order to find the roots, or we can just write this down as the x minus 4 times the x plus 2. We can just factorize this, right, using so-called VS theorem, and this is going to be equal to the 0. You see, so if you just open up the brackets, it's going to be like, or I think I made a mistake. So here it should be 2, and here it should be plus 4, right? So if you open the brackets, you're going to get exactly this expression. Okay, so one of the solutions is going to be minus 4, another solution is going to be equal to the 2. Please note that you can't just present these two solutions without checking them. So essentially what you need to do is you need to put both of the solutions into the equation, into the initial equation, and check whether this is true or not. The initial equation was logarithm of base 2 of x plus the logarithm of base 2 of x plus 2. This is equal to the 3. So we're going to substitute x to be equal to the 2 to here. So this is going to be the logarithm of 2 of 2 plus the logarithm of 2 of 4. This is equal to the 3, which is correct. Now, if you just try to plug in minus 4 to here, it doesn't work because the logarithm of 2 of minus 4 plus the logarithm of 2 of minus 2 is not equal to the 3. So we know that they are even not defined, right? Okay, so the argument of the logarithmic function should be always a positive number. So this is not going to be the root. So this is not the root. Essentially, the answer to this question is going to be simply x is equal to the 2 as the solution of this equation. So we are going to use the properties, the three properties of the logarithmic functions extensively in order to solve the equations which involve the logarithms and the exponentials. So I hope this video was helpful for you.